In this video, I'll explain you how to find the electrostatic potential with respect to dipole on an arbitrary point. Now, this arbitrary point will be given, the distance will be given from the center. So, in the question they will be saying that at a distance of r away from the center of the dipole and making an angle of theta with the dipole moment. So, dipole moment will be along the line connecting minus q and plus q. Okay. Now, how can we find potential at this point? We need to separately find the potential at this point due to minus q. So, I will mark minus q here and I will mark plus q here. Okay. It doesn't matter, but I will make it in this way because that is how it is given in NCERT. Okay. Now, we have to find the potential with due to plus q on this point, that is V plus q we have to find, and we need to potential due to minus q on this point, V minus q we have to find, and after that we have to sum both the potential to get the actual potential with respect to the dipole at this point. Okay, now to find V plus q, we need to know the value of q and also the distance in between these 2 points. So we need the distance to find V plus q, we need this distance to find V minus q. You know the equation, right? 1 by 4 pi epsilon 0 q by r. So we need q and r to find potential. Okay, now I'll give you an easy assumption that you can take here to get the value of this distance. Now when you are having two long lines in this way, if you know any of the length of any of this length, I am going to take the length of the shorter part as r, then you can easily find the total length of this one without actually measuring the whole length. How? Just draw a perpendicular from this line. This is the perpendicular, for example. Okay, now if this is r, this will also be r. So after that, what you have to do, you have to only measure these two distance. Let's say this is L centimeter, then the total distance will be r plus L. This is centimeters or meters. So this is an assumption you can follow only when these two are very long and the distance in between them or the difference is small. Here in this case, you can apply the same assumption. How? From here you can draw a line. Now you know that this distance is very small as compared to the total length. Now you can assume that this distance is equal to this distance. So if this is r, if this distance is L, this will also be L. If this is L, this will also be L. Okay, now we know the total distance r here, right? From here we have to go to here. Now how can we do that? We have to first find this distance and we can equate it with this one. How to find this distance? We know the total distance. Subtract this, then we will get this distance and you can equate it with this. How can we find this value? We know A. Okay, now this is hypotenuse and this is base and this is height. Now if this is hypotenuse, we can easily find this value using which trigonometric property? Cos theta. So cos theta is adjacent. So let's say adjacent is x divided by hypotenuse A. So what is x? X is equal to A cos theta. Okay, so this one is A cos theta. That is this distance. So what will be this distance? R minus A cos theta. Okay, now if this is r minus A cos theta, this will also be r minus A cos theta. Now similarly, we can even find the value of this one. How? Just draw this line and draw a perpendicular in this way. Now this distance will be equal to this distance. Now these are similar triangle. If this is theta, this is opposite angle theta. So what is the property of similar triangle? You can apply that. You will come to know that if this is A cos theta, this will also be A cos theta. A cos theta. So this one is equal to this one and this one is equal to this one and this one is equal to this one. Basically the ratio will be equal, but as these two are equal, the ratio will be 1, so that this will also be equal to this one. You can apply the trigonometric properties of similar triangle and get the value as A cos theta. Okay, I'm not explaining it over here, but this value will be A cos theta. Now if this is r, this is A cos theta, the total will be r plus A cos theta. So that will be here as well, r plus A cos theta. Okay, so this is r plus a cos theta, this is r minus a cos theta. So this is not given in your NCERT, they have directly given the value. So don't try to memorize, do in this way so that conceptually you can understand, and even in your examination you will be able to deliver it. Okay, now we can easily find the value of v plus q. What is v plus q? This one, 1 by 4 pi epsilon 0 plus q divided by, what is the distance? R minus a cos theta. Similarly, what is v minus q? V minus q is 1 by 4 pi epsilon 0 minus q divided by this one, r plus a cos theta. Now how we will get the total value of potential? Add these two, v plus q plus v minus q is equal to, add these two. So I am going to take common term out from this. 1 by 4 pi epsilon 0 into q is a common term. I am going to take it out. 1 by 4 pi epsilon 0 q. Now this is 1 by r minus a cos theta. This is minus 1 by r plus a cos theta. Do that. You can just take the q by 4 pi epsilon 0 out from this term and then add it. Okay, now this is q by 4 pi epsilon 0, LCM of these two, cross multiply. So r plus a cos theta minus of r plus a cos theta. So what I have done, I have multiplied across and then multiplied with negative. So this will become minus r plus a cos theta divided by a plus b into a minus b. What is that? R square minus a square cos square theta. Okay, so r and r will cancel. What you have inside? A cos theta plus a cos theta, 2a cos theta. Multiply with q. That will be 2aq cos theta divided by 4 pi epsilon 0 r square minus a square cos square theta. Okay, so here you will have theta also, because that is how you can locate the point of locate the arbitrary point. It will be given with distance and the angle that this vector makes with respect to q. This is a very important relation. Potential due to a dipole. It can be a 5 marker. Clear? Now how can I check whether this value is correct or not? We can simply do it with substituting these values of theta for equatorial and axial plane. Now one thing we know, in equatorial plane potential is 0. Just substitute the value. In equatorial plane this line makes an angle of 90 degree, right? Now if that is 90 degree, substitute it here. What will be that value? Cos 90. What is cos 90? 0. So the moment you multiply, the whole term will become 0 and v at equatorial is equal to 0. We have checked it with equatorial value and we will also check it with axial value. So with axial, this line will come here. Okay, then only we can find the value of potential at axial line. Okay, so what is the angle in between these two? 0. What is cos 0? 1. So substitute 2aq divided by 4 pi epsilon 0 r square minus a square. Cos square 1 is 1 itself. So r square minus a square. Okay, when a is small compared to r, a can be ignored. Okay. Now we will see whether this equation hold true with the relation we have derived for to find potential at a point on axial line. What was the equation we have derived? That was P divided by 4 pi epsilon 0 r square. Basically the equation was r square minus a square, but we have neglected a square when a is very less as compared to r. So this was V axial line. Okay, this was the equation we have derived. We will see whether we can get the same equation with this thing. Now on an axial line, this line will become parallel. So while finding the potential at axial line, this line will become parallel with the axial line. Okay, with equatorial line it is 90 degree, then with the axial line the angle will become 0. Now substitute cos 0 here. Theta is equal to 0 in this equation. That will become 2aq cos 0 1 divided by 4 pi epsilon 0 r square minus a square cos square 0 Cos 0 is nothing but 1. So that will be 1 square. What is that? R square minus A square. Now this is equal to 2aq is P divided by 4 pi epsilon 0 R square minus A square. See, it's the same equation, right? So one way you can do is you only have to learn this one, and after that this you can even follow in your CBSE or PUC board examination. Only have to learn this derivation, and after that substitute the value of theta as 0 for an axial line, as 90 for an equatorial line. You will still be able to find the value of V axial and V equatorial. Okay, so P divided by this, when A is very less than R, we can equate it as P divided by 4 pi epsilon 0 R square. Clear? Thank you.